We have a MacBook Pro. It's a 15 inches. The description says it's dead. This is an A1707. Okay, so as you know, we uh, we do not plug power to the device until we are sure what state the device is in. So first thing first, let's take out the back cover. That seems to be one out. Mm-hmm. Hmm. Interesting. Uh, it's a bit thrown out. I don't know why they have to put the screw back. I mean, if it's one out to change it, I put it back. Okay, so this was definitely been assessed before. So the only devices that will come down here will be devices that require advanced repairs. If they're not advanced, they're definitely not going to be down here. Okay, so it's clearly been assessed. It's been opened and assessed, and then they confirmed that it's an advanced repair. That is why we have the device here. See, the fines are quite dusty, but that is completely irrelevant to what it is that we currently having, which is the issue at hand. So let's start by disconnecting the battery. So as you know, this is the model that has the dual battery design. You have the battery data cable as well as the main battery power line. Let's open up the board view. This is going to be, let's see, do we have it previously opened? Mm, it doesn't seem like it. Let's check the other board view. Okay, here you go. So first thing first, let us check for short on our PP bus line. Although we not with the A1707, we it's not a common failure on the A1707 to have a short on your PP bus line. However, a common failure on the A1707 will be a short on the 3.3 volt SS4 SOC PMU. So on this line, you usually get a short on that line, and that will be caused by one of the caps. So PP bus short is not really a common issue on the A1707, and also another common issue you will find is a failure of one of the CD3215, which would then mean you get a 5 volt on your PPDC in instead of a 20 volt. So PP bus is not a short on your PP bus line is not a common thing on the A1707. However, that said, we are still going to check it out to obviously to build our case. So let's start by measuring for short on our PP bus. So as also we are going to leave the small multimeter on continuity measurements while we leave the big meter for voltage as well as your diode measurements. So first thing first, our black probe to ground and then our red probe. There's two fuses here. We are going to confirm if we have a short on the line, and we don't. Both fuses are on the same line, so if we don't have a short here, it means we do also not have a short here. Now let's check this side here. We have a beep on that side, and that's it. So that's the section I was mentioning. So usually I do find to have a problem on this line, especially with A1707. So in this state, you obviously get your PPDC in is going to be fine. You will have your 20 volt, you will have your PP bus voltage, but the device will not start. So while it's in this state, you have your PP bus voltage will be present, which is going to be 12.6, as well as your PPDC in. Obviously, if it gives you 12.6, it tells you that you have your 20 volt, it's there, because if you're not getting 20 volt, you're not going to get 12.6. So let's just connect power to it. This sorry, can you disconnect that? I just want to show you guys what I'm talking about. There's no harm in that line, in us introducing power onto the board. It's not going to affect anything in the line, even though there is an active short on the line. So let's connect power to it. So we are expecting the device not to start, and then we are expecting to get 12.6 volt on our PP bus, which is we can measure that on the fuses here. So as you guys can see, that is 12.6 volt, and that is because we have 20 volt on our PPDC in. So if we check here also, if we check, this is our CD3215, this is going to be, this fuse is going to sit on our PPDC in line. So let us check that, and then we see that we have 20 volt. So, but the device is not going to start because of the short that we have on that line. So what we are going to do is we are going to quickly take the board out and locate the capacitor that is creating that short, and afterwards that should address our issue. So with the A1707, that is a common thing to look out for, especially. But again, you have to tailor down your issue. As you guys can see, we clearly do not. We clearly have PPDC in voltage. We clearly have PP bus voltage, and we also do have PP3V42 voltage, because if we didn't have PP3V42 voltage, that is one of the required rail to that allows your PPDC in to be generated, which is the 20 volt that you're getting now. So if your PP3V42 was not present, then you will have issues getting your PPDC, getting 20 volt on your PPDC in. So before, yes, it's a common issue, but make sure you actually narrow it down to that. And then again, I will say, every action that you take on your repair has to be informed by the result of your troubleshooting. So you don't just go ahead and start looking for that cap, or the methodology that was applied in a particular video that you see. Always make sure that you are able to build your troubleshooting to know why you do what you do. I don't know if it makes sense. Now, this failure is not common on the A1990s. This is a common failure on the A1707s, which is the 2016-2017 touch bar 15 inches. Okay. Do we have any cable that is pending? Okay. So the board is out. Let's put the chassis on the side. And let's flip the board to the other side to get to see what is causing our short. We are still going to look on that side as well, but let's see what we have on the other side. This is a 2016 board, not a 2017 board. So one of the ways you can tell the difference from 2017 and 2015, I'm just going to show you. So this is a 2016 board, correct? So just one of the ways you can tell a 2017 board is this cap here. You see this cap here? Yeah. It's not going to be present on a 2016. Everything else, you almost see everything else to be the same physically. Yeah, you see that particular capacitor here? You only find that cap on the 2017. That cap is not on the 2016. So one of the ways you can tell that if your board is a 2016 or 2017, for example, this is a 2017 and this is a 2016. So 2016 will have that cap will be present, And then on your board view, let's see, let's flip the board to the other side. So this, as you can clearly tell, because the cap is not here, you can clearly tell that this is the board for 2017, sorry, 2016, because the cap is not featured here. That cap, you see this, that you see here, it's void. The cap is not here, whereas the cap is here. And then another way you can tell the differences will be the board numbers. So this is the physical difference that you will see, yeah? You see that? And then the board numbers, if you check the board number of this, you will get, so this board number, wait, okay, let's check this one. So this is 281, yes? 281, and that is the 2016. Now, this is the 2017. Let's check board number here. You will get a slightly different reading. Let's see, which is a 2016, okay? 2016, 2017, okay. But then you can, the board numbers are, you can use the board numbers to be the same. I don't see the board number here, even though on the 2016 you can easily find it here. So this is 281, 200281, which is this one. This is the 2016. However, the board views that we use the same board view for 2016 for the 2017, and then the only thing that stands out on the 2017, one of the ways you can easily tell, is just the presence of that cap. So when you see the cap, you know it's a 2016, 2017. If the cap is not there, you know it's a 2016 board. So with the cap, it's 2017. Without the cap, it's 2017. No, without the cap, it's 2016. With the cap, it's 2017. Okay, so let's see. If we click on, so let's go back to our issue. So here we clearly see that the pins are only connected here, correct? So we will be looking at C4203, C4206, C4205. But most of the time is between this, or it's basically around here. Yeah. So let's check this one first. It's C4203. So we are going to remove that first. Okay, so that is out. We can measure the individual cap. That's not our problem. And then let's check the next one, which is this one here. And by the way, they also do not look like our problem, because usually the ones that are faulty will have some kind of oxidation around them, which we do not see on this too. Okay, so that is out. So the next one we want to check now, it's this here, C4205. C4205 will be this guy here. Is that it? C4205. This is, yes, C4205, because the next one is a resistor. So that is going to be C4205. So this one here. I get. Did anybody take my? Okay, I was looking for my tweezer because that's not. I'm not getting proper grip from it. So let's check the. Is this the one we just took off now? Okay. Let's see. That's not our problem. Let's see this one. We measure. That's not our problem. That's not our problem. And that's not our problem. Okay, so let's go check the section of U. Okay, let's see that. The section of U4200. Let's go to the other side. So we want to, let's go back. So um, here, now we, now let's check the section of U4200, which is, we'll have to go to the other side. No, before we do that, let's put back those caps. That's, so we know we are not coming back there. Hmm. Um, you, so remember to test to see if the touch bar, as I see that's melted, the connector, and you replace that. Okay, so I think our problem is this guy here, which is going to be C4204. It's, that is also sitting on the line. Let's remove that. That cap is not looking good. I'm not sure if you guys can see it, but the cap is not looking good. Yeah, it's definitely, can you see that? It's definitely, I'm not sure you guys can see it. You see, it looks fine this side, but if I flip it to the other side, you see the way it looks on this side? In any case, let's measure to see what we get. And that's our problem. So that cap is our problem. We just need to replace that, and we'll be good to go. Okay. So what you want to do, especially when you have an issue like this one, the first thing you want to do is to check around this section here, which is easier to. So oftentimes you get some kind of oxidation around the components, around your capacitors here, especially the capacitors. They are the common ones that fit on that line. And if everything looks fine here, then you want to go to the other side of the board, which is the section of U4200. And then you see what we're basically doing is we're checking out the caps first. We're not, you see, it has many connecting pins with U4200, but then we're not worried about that. So we have to first of all worry about the caps on the line. So we have to check C4204, and then we saw that it wasn't looking okay. And even though that's C4461, we didn't really bother about that. There was also C4444. We didn't worry or bother about that. There's 4202. There is 4207. We didn't worry about that because we saw that C4204 was not looking okay. So let's now see if our short is gone. Yes, we did confirm by measuring on the cap itself that the cap itself is shorted. So but let's measure the line now to be sure that the cap that we just installed now is also not faulty. And that is fine. That's our ground, and that is our main line. That's good. So the next thing we want to do now is quickly clean that section of the board where we replaced the cap, and we should have a working board. remember, so I'm thinking actually you can just plug the torch bar just to. Anyway, when you're cleaning this section of the board, this angle, be careful not to apply pressure. You could break it off. Yeah. Okay. So see if we have a working machine now. When the device is being finalized, then it's going to be cleaned off definitely. But for now, we just want to test to see that we have a working board. And also because we're trying to race against time, we're quite late. Peter needs to leave. Okay, we are going to connect some of the cables that we need, not all of it. As you know, if we do not connect the trackpad, the keyboard will not work. Okay, but the keyboard is not dependent on the trackpad is not dependent on the keyboard, but the keyboard is dependent on the presence of the trackpad. So let's be sure that that works. Expect to see a fine spin. It's a beautiful fine spin. Suspect that's fine. Let's see. Do we have feedback on our trackpad? Yes, we get feedback on trackpad. It's a chime. It's a beautiful Apple logo. Uh, so we are going to try to cover the name of the account. I'm pretty sure the touch bar should work. It doesn't look much damaged now. I suppose. Yeah, I believe the touch bar will work. Yeah, I believe it will work. So that's it. We can just touch and see if it responds to touch. Yeah, it works. Yeah, it does work. Okay, yeah, so as you guys can see, that's a successful repair. Peter is going to take over from here, which is he's basically going to make sure the device is clean, and then it will be finalized. Thank you guys. I will see you guys in the next one.